Hi, welcome back to our third example for 6.2 recursive procedures. In this example, we're going to look at medication in the human body. So it says here, a runner injures her knee in a race. Her doctor prescribes physiotherapy along with 500 milligrams of an anti-inflammatory medicine every 4 hours for 3 days. The half-life of the anti-inflammatory medicine is approximately 4 hours. This means that after 4 hours, about half of the medicine is still in the body. If you remember the half-life questions, remember the half-life period tells us how long for only half to remain. Okay, so part A, it says make a table of values showing the amount of medicine remaining in the body after each 4-hour period of time. So I'm going to use Excel to model this. So it's a great way to show the recursion process. So here I just have a table. I've already kind of labeled them ahead of time. So we have the 4-hour intervals in this column. We have the amount of medicine in this column. So if you're taking the medication every 4 hours, you could take it 4 times a day. So at the start in the morning, and then you would take it 3 more times before going to bed. Do that for 3 days. That's a total of 4 times 3. It's a total of 12 times you would take your medication. So I'm just going to increment this at 1 and the next one at 2. So this column is just showing the amount of 4-hour interval. So I like to populate this so it shows 12. Okay, because I'm on the iPad, I use the fill button to do that. So on your desktop, I think you can just drag the box down and that works. So the amount of medicine. So this part now, um, after a 4-hour interval, she's going to have half of her previous cell. So we're going to write 0.5 times, and then I'm going to click on the cell just above. That's cell B2. And then I'm going to add another dose of 500 milligrams. Okay, and I can enter, and then you can see she would have 750 milligrams at that point. Okay, the great thing about Excel is I can repeat a process by using the fill command here, and I can drag this down, and it's going to keep calculating for me up until the 12 intervals. So you can see what's kind of cool. It automatically does this, so it's always taking half of the cell just above and then adding 500. So for instance, if I click on this one here, so it's going to take half of so this cell is equal to 0.5 times B7, which is the 984.375, and then another 500 on top of that. So you can see it's always taking half of the previous cell and then adding 500. So this last cell here is B14, okay, because it's in the B column and the row is 14. So this cell is equal to half of B13, the previous cell, plus 500. It's really cool how the medication works this way with the half-life of 4 hours. If you keep taking 500 milligrams every 4 hours, what it does is it ramps you up to a maximum dosage, and you can see what's going on here. This number looks like it's getting closer to 1,000, and I can drag this down, and you can see it's getting closer and closer to 1,000. So notice it actually never ever reaches. So I believe the other questions in A, B, and C are going to get to that. Let's go back to the handout. So we did part A. Part B, write the amount of medicine remaining after each 4-hour period as a sequence. Write a recursion formula for the sequence. So that's not too difficult. So I remember a few of the terms in the beginning. It was 500, 750, 875. Let's go back to Excel. Then it was 937.5. Okay, and the other one was 968.8. And this keeps repeating until we get something that approaches like 1,000. So the 12th term, what was the 12th term? Yeah, if I rounded that up, it'd be 999.9 if I wanted to round up. So maybe I'll erase this last 9 here. Okay, so that's part B. So that's what it would look like as a sequence. How can I write this as a formula? Well, I could say any term in the sequence is equal to the previous term times a half. So I'm going to throw a bracket around there, and I'm just going to write times a half. And then we also need to add the 500 for the new dosage. So to make it look a little bit better, we could write it as a half of t n minus 1 plus 500. That would be my recursion formula. Okay, be careful with these subscripts. Okay, don't write this out like this. Okay, this doesn't look like a subscript. This looks like the nth term minus 1, whereas this means the previous term because it's t of n minus 1. Okay, so there's a difference. All right, in part C, it says graph the sequence. So Excel can actually do that for us. So I'm going to see if I can do that on here. We're going to highlight this. We would be plotting this. I believe we can go to data. No, we can't. Maybe insert a graph. Let's see. Charts. We'll do an XY scatter. So it's plotting. Okay, that actually worked quite good. Thought I was going to plot a little differently. So this is actually a really nice chart. This is exactly what you would want if you needed exactly 1,000 milligrams of medicine in your body. If you take it every 4 hours because of the half-life, you could then kind of quickly ramp up to your maximum dosage and then hold it for the time being. Okay, so that is part C. I'm just going to copy that over. I think I could paste that right there. So sorry guys if you're doing this by hand, but that would be the graph. So you can look here though, you can see where your axis, where your intervals should be at and what they could be labeled to. So, all right, last question, part D. It says, describe what happens to medicine in the runner's body over time. So from the graph, the amount of medicine in the body increases until it reaches a constant level of 1,000 milligrams. Okay, is it ever possible for it to exceed this? Well, no, because if we have 1,000, then as soon as we hit the next 4 hour interval mark, which would be at 11, that cuts in half to 500, and then we add 500 milligrams and it brings it back up. So there's no way that we could exceed that. Okay, that's it for 6.2 recursive procedures. Hope you guys have found this helpful. I will see you later.